In this video, we will discuss structural buckling. You may be wondering what buckling is and why simulate it during the design phase. The technical explanation is when an object is very long in comparison to its cross-sectional area and becomes unstable under a compressive load. You've probably seen this in plastic furniture or standing on something that wasn't intended to hold the weight of a person. The instability can end in a catastrophic failure, which personally I'd rather see on a computer. So let's avoid buckling early on by using the simulation capabilities in Fusion. We are provided with a buckling load factor, which multiplied by the load will cause buckling. A value of less than 1 means that buckling will occur with the current load. Typically, we look for the lowest buckling load factor from the different modes. Let me show you how to set up and run a structural buckling study. We bring our geometry into the simulation workspace. Select structural buckling as the study type in the new study dialog. At this time, we can access the study settings and set the number of vibration modes. The displaced shape from buckling is based on vibration modes. The default of 3 is typically enough. We can also adjust our mesh settings. Now we can modify our materials if they weren't assigned in the modeling space. We can assign constraints to keep the model from moving infinitely. Fixing the bottom of the 4 legs is like if it were sitting in grass and the legs couldn't slide like they might on a slippery floor. Assign our loads. This can be determined by design criteria, or we could use a value of 1. The advantage of using 1 is that the load factor reported back to us will be the force required to cause buckling. We assign contacts that are appropriate for our model. In this case, the legs are coincident to the table, and we can use the automatic contact generator to create bonded contacts. Now, we can solve our analysis in the cloud. It's worth mentioning that structural buckling analyses cannot be solved locally. They must be solved in the cloud. Once the analysis is finished, we have the same results mentioned previously for the different buckling modes. Since we used a load of 1, the buckling load factor is the force required to cause structural buckling. For this setup, about 195 pounds. I hope this helps. Happy simulating!